Okay, everyone. From the first video, there were two main definitions of statistics as a field of study. One of them was organizing, collecting, and displaying data, and the other one was doing something with the data, inferring something about the data. Both of those, however, relied on getting data in to create statistics about. So today, the rest of today's videos are going to focus on just that. Collecting data and being able to display that data in an effective way. So this first bit of data I'm going to give you, it refers to you, but not you personally. This is another Math 105 class's data, only because I can't get this from you yet, and I'll explain why in a second. So here it is. And I want you to look at this data and see what you think it is. This does apply to you as well. This just isn't your data. So think about this for a second and then we'll regroup. Okay, so again, the reason I don't have this for you yet is I'm recording this video in the middle of week 3. This data is usually collected somewhere around week 7 for me. So because we're doing this pre-recording videos and flipping class, I don't have the ability to be with you right before collecting this data. So this is what you're looking at. These numbers, I call this raw data, just FYI. Each one of these numbers refers to a student from winter term 2020. I don't know who's whom, but somebody has 8, somebody has 1, somebody has 10, a bunch of people have 0. So I don't know if anybody has thought of it yet, but what you're looking at is actually the number of quizzes all of my students that term had left to do as of week 7 in winter 2020. So if you think about it, you have to do 10 quizzes by the end of the term. You know that. And at any point during the term, you either have none left to do, or 1 left to do, or 2, or 3, or 4, or 10. I mean, there was one person last term, there they are right there. They had 10 quizzes left to do by week 7. That one person had 10 quizzes left to do by week 7, which is very interesting. 2 people had 9 quizzes left to do. 6 people had 8. 8 people had 7, and so forth and so on and so forth and so on and so forth and so on. This is called a frequency distribution, because hopefully you're agreeing this is one heck of a lot easier to look at than this. That is a disaster, an absolute and utter disaster. I mean, it's raw data, so it's good, but also it's hard to look at. It's hard to kind of sort out where the groups are. Like, I see a bunch of zeros, but I think that's just because 0 is shaped in a way that has that big gap in the middle. 8s and 6s kind of look the same to me. And an 8 kind of also looks like a 3. So it's hard to differentiate those. So a frequency distribution is a really handy way of keeping track, especially if you can parse out all these. If you know that the smallest number is 0, the biggest number is 10, then you can just make like a tally sheet as you go, which is fabulous. Like, it would be hard for me to know over here that there are more 3s and 5s than anything else, unless I actually sat down and did this. So that's why I like frequency distributions. Another way of collecting this data is in a relative frequency distribution, or a percentage frequency distribution. What this does is it sums up the total number of folks, so 8 plus 3 plus 4 plus 14 all the way down. We sum those up, and then we divide each of these by that sum total and get a percentage. So 11% have no quizzes left to do, roughly 1 in 9. 4%, roughly 1 in 20, have 1 left to go. 5%, 1 in 20, have 2 left to go. 19%, that's about 1 in 5 people. That's a lot. That's a large percentage. About 1 in 5 have 3 quizzes, and so forth and so on. So that's another way of looking at this data with these counts in the same way. And we'll talk more in the next video about when I kind of like counts and when I kind of like percentages. There's a time and a place for each, and we'll discuss that in the next video.